This video is to help you learn how to factor by grouping. So we have already looked at a couple ways to factor polynomials already. We learned how to factor out the GCF, which stands for the greatest common factor, which is like undoing the distributive property. So for this binomial right here, the greatest common factor is 3x, and then you'd be left with x minus 3 on the inside. So 3x times x gives you 3x squared, and 3x times a negative 3 gives you negative 9x. So that's the first way we learned how to factor. And then we've spent the last couple of days looking at factoring a trinomial, which was undoing double distribution. So that was when we played the game, what multiplies to get c but adds to get b. So if I had negative 5 and negative 2, those multiply to get a positive 10, but add to get a negative 7, so I could factor it by x minus 5 and x minus 2. So those are the two ways that we know how to factor right now. There's a third way to factor called factor by grouping. Okay, and this is helpful when we have 4 terms in a polynomial, or it will also be useful next week. We're going to use this method to help us factor more trinomials. So we're going to look at this kind again, and we're going to look at how factoring by grouping can help us with this kind. But for today, we're going to learn about factoring by grouping, just looking at problems that have 4 terms in a polynomial. So we're kind of taking a sidestep from what we were doing with factoring and solving trinomials, and we're going to talk about factoring by grouping. Okay, so here's a polynomial with 4 terms. All right, and the reason, remember, mathematicians are not clever. So the reason that we call this method factoring by grouping is because we're going to group 2 of our 4 things together. So usually you can group the first 2 terms together and the second 2 terms together. Just like this. So I haven't really done anything. I just put parentheses around the first 2 and put parentheses around the second 2. Okay, now I'm going to factor out the greatest common factor from each one. So let's see, I'm going to factor out the greatest common factor for each one. Okay, so this first one would be what? 3p squared. So 3p squared. And that would leave me with 4p minus 7 on the inside. Then I'm going to factor out the greatest common factor in this guy, which looks like 7. So if I factor out a 7, I get this plus sign right here from this plus sign right here. So if I factor out a 7, I'm left with 4p minus 7. Now when you're factoring by grouping, if you have factored correctly, something magical should happen. That what's left in this parenthesis should be the exact same as what's left in this parenthesis. If that hasn't happened, you've done something wrong, okay? But when these two are the same, you can almost think of them as factors on their own and factor them out as a greatest common factor. So watch what happens here. If you factor out 4p minus 7, if you take this out and you take this out, what are you left with? Well, you're left with 3p squared plus 7. So then you have times 3p squared plus 7. And that is how you would write this in factored form. Now you could check your answer, as always, by using the area model. So you could check your work. You don't have to do this part, but it's never a bad idea to check your work. Let's see, we would have 4p minus 7 and 3p squared and a positive 7. So this box would be negative 21p squared. This box would be 12p cubed. This box would be 28p. And this box would be negative 49. This time there's no like terms to combine. So our answer is the exact same as what we started with, which was 12p cubed minus 21p squared plus 28p minus 49. Okay? So it's how you factor by grouping. You factor out, or you group together two binomials and then factor out the greatest common factor. So let's do another one together. So first thing I'm going to do is group two binomials like this. And I'm going to pull out the GCF, or the greatest common factor, out of each parenthesis. So this guy, I could pull out, what, a 2v squared, which would leave me with 3v minus 8. Then I see what I can pull out here. Looks like a 7. So the greatest common factor of 21 and 56 is 7, which leaves me with 3v minus 8. Aha! Something important has happened here. These need to be the same, and they are, so I know I've done this right. So then you can pull these out. So when you pull out 3v minus 8, you are left with the 2v squared plus 7. So you would have times 2v squared plus 7. Again, you could use the area model to check your work. You could plug in, let's see, 3v and negative 8 and 2v squared and 7. And when you find all these areas, you will indeed get your original problem back. All right, so you try this one. I want you to pause the video and try this problem. And then once you have it finished, you can check back and check your answer. All right, so to check this, we're going to group our first two together and our second two together. And let's see, pulling something out of here. Looks like, what, 21k squared? So that would leave me with k minus 4. And the second one I can pull out of 15. So again, I'm left with k minus 4. So I'm going to pull these guys out. Pull those out. So I have k minus 4 times what's left, which is 21k squared plus 15. All right, you could use the area model to check it. You don't have to. We're going to do one more where I want you to try it. So go ahead and pause the video. Try it, and then we'll go over it. All right, so again, group the first two together, group the second two together. Let's see, I can factor out a 5v squared. And I'm left with 5v plus 1. I factor out a 6 in this one. And I'm left with 5v plus 1. So these are the same, which is good. So I'm going to pull those out. And I have 5v plus 1 times 5v squared plus 6. If you have any questions, come see Miss Fike in the morning. Otherwise, be ready to divide yourself into the 3 groups of, I totally understand this, I need some more help, or I need to watch the video again.